Hello and welcome. Today we are going to discuss about special types of quadrilateral like trapezium, parallelogram, rectangle, rhombus and square. So this is a quadrilateral, but side AB is parallel to side BC. So if one pair of opposite sides of a quadrilateral are parallel, then it is called a trapezium. So in this trapezium you can see DC is parallel to AB, but DA is not parallel to DB. That means one pair of opposite sides are parallel to each other. So this becomes a trapezium. Now you can see DA is a transversal to these parallel lines. So angle D and angle A are supplementary because they are consecutive internal angles. Similarly, CB is also a transversal to these parallel lines, and that is why 108 plus 79, that is 180 degree, because they are supplementary as they are consecutive internal angles. This angle and this angle are consecutive internal angles. Now in a trapezium, if the non-parallel sides are equal, then it is called the isosceles trapezium, like this. Side DA and DB are not parallel, but they are equal. This type of trapezium is called an isosceles trapezium. Here you can see vertex D and C coincide, and that is why the isosceles trapezium now become a triangle, and this triangle is an isosceles triangle. Now the question is, how can a trapezium become a parallelogram? A trapezium has one pair of opposite sides parallel to each other, but if both the pairs of opposite sides are parallel to each other, then it becomes a parallelogram. See here, this is a parallelogram, and in parallelogram we'll discuss about the theorems of parallelogram, like the opposite sides are equal, DC is equal to AB and DA is equal to CB. That we'll discuss and do some exercise also. We'll prove the theorem. And opposite angles are also equal, that also we'll discuss, and each diagonal bisects the parallelogram. For example, this is a diagonal AC, and this diagonal bisects this parallelogram into two equal triangles. These two triangles are congruent, that we will prove in our subsequent videos or today itself. So a rhombus, that let us see, it become a rhombus if the sides are equal. So like this, you see, this is parallelogram, opposite sides are parallel and all the sides are equal, so this become a rhombus. Now this rhombus or this parallelogram become a rectangle, yes, if the angles are, all angles are 90 degrees, so it is a rectangle. Sides are not equal, but if the sides are also equal like this, then it become a square. Now it become a square. So all these things we'll discuss now. Today we will discuss some theorems on parallelogram, rectangle, rhombus and square. So the first theorem is theorem number 2. In a parallelogram, opposite sides are equal, opposite angles are equal, and each diagonal bisects the parallelogram. In this parallelogram A, B, C, D, we have to prove that opposite sides are equal. That means DC is equal to AB and AD is equal to BC. And also, if we draw a diagonal DB, we have to prove that this diagonal bisects the parallelogram. That means triangle ABD and triangle CDB, they are congruent triangles, that we have to prove. Let us prove the thing. So we draw a diagonal DB. This diagonal divides the quadrilateral into two triangles, triangle ABD and triangle CDB. And suppose this angle is 1 and this angle is 2. DC is parallel to AB and DB is a transverse. This is like this only. This is the transverse. So this angle is equal to this angle because this is called the alternate angle. So we can write in triangle ABD and CDB, AB is parallel to CD and DB is a transverse. So angle 1 is equal to angle 2 because these are alternate angles. Similarly, suppose this angle is angle 3 and this angle is angle 4. AD is parallel to BC because these are opposite sides of a parallelogram, and BD is a transverse. This is like this only. These are the parallel lines and this is the transverse. So this angle will be equal to this angle, and these are again the alternate angles. So let us write AD is parallel to BC and this time also DB is the transverse, and so angle 3 is equal to angle 4, alternate angles. Now in the triangle ABD and CDB, you see this side DB is common side for both the triangles. So let us write side BD is equal to side DB because these are common sides. What we get? Two angles are equal and one side is equal, and this is angle side angle postulate. So according to that postulate, triangle ABD is congruent to triangle CDB, angle side angle postulate. And if that is so, DC is equal to AB and AD is equal to BC because the congruent triangles mean each and every parts of the triangles are equal. Also, this angle is equal to this angle. So we write angle A is equal to angle C. What are these? These are opposite sides, these are also opposite sides, and these are opposite angles. So number 1 and 2 of the theorem is proof that opposite sides are equal and opposite angles are also equal. Now the third is that the diagonal of the parallelogram bisects, that means it divides into two equal triangles or two congruent triangles. Since these are congruent triangles, parallelogram is bisected by the diagonal BD. Similarly, if we draw a diagonal, say AC, we can prove that AC also bisects the parallelogram into two equal triangles. Now what is congruent? You can see, suppose this triangle is congruent to this triangle. What does it mean? That these two triangles are exactly equal in shape and size, and if we overlap one triangle over the other, then we cannot distinguish the two triangles. So this is the principle of congruence, and so these two triangles are congruent triangles. Okay. So what is this? This triangle and this triangle are congruent. That means this triangle is, say, this one, and this triangle is this one. I am separating only for the sake of understanding. Now theorem 3 is the diagonals of a parallelogram bisect each other. ABCD is a parallelogram. If we draw two diagonals BD and AC, they will cut at a point, say O. Then we have to prove that OD is equal to OB. That means BD is bisected by AC. Again, we have to prove that OA is equal to OC. That means AC is bisected by DB. So let us see how we can prove this. So we have to prove that OB is equal to OD and OA is equal to OC. In triangle OCD and OAB, you see OCD and OBA or OAB, these are two triangles. So in these two triangles, suppose this angle is angle 1, this is angle 2, and this is angle 3, and this is angle 4. Now DC is parallel to AB and CA is a transverse. So angle 1 is equal to angle 3. So can we write that angle 1 is equal to angle 3 because they are alternate angles and DC is parallel to AB and AC is transversal. Likewise, we can say that angle 2 is again equal to angle 4 because this time DB is the transversal. So angle 2 is equal to angle 4, alternate angles, and this is the reason for being equal. Two angles we get. Now about the sides. So we know that in a parallelogram, according to Theorem 2, opposite sides are equal. So AB is equal to DC. So we can say side AB is equal to side DC. So two angles are equal and two sides are equal, and this postulate is again angle side angle postulate, and therefore triangle OCD is equal to triangle OAB. So both these triangles are congruent triangles. So if they are congruent, then what we can get that OA is equal to OC and OD is equal to OB. So what we get? OA is equal to OC and OB is equal to OD. And this we have to prove that. To prove that OB equal to OD and OA equal to OC. So this is the proof of the Theorem 3. The diagonals of a parallelogram bisect each other. That means AC diagonal bisects BD diagonal and BD diagonal bisects AC diagonal. Okay, fine. Now theorem number 4. If a pair of opposite sides of a quadrilateral are equal and parallel, it is a parallelogram. We are given a quadrilateral, not a parallelogram, but we have to prove that it is a parallelogram, and the condition is that opposite sides are equal and parallel. ABCD is a quadrilateral. Remember, this is quadrilateral. ABCD is a quadrilateral, and given AB is parallel to DC, so AB is parallel to DC, and also AB is equal to DC. So we draw a diagonal AC. So you can write construction, draw a diagonal AC. So this diagonal divides the quadrilateral into two triangles, ABC and CDA. So in these two triangles, you see, it is given DC is already equal to AB and AC is equal to CA. That means they are common. This angle 1 is equal to angle 2 because DC is parallel to AB, and therefore angle 1 and 2 are alternate angle and CA is a transverse. So we can write in triangle ABC and triangle CDA, DC is equal to AB. Why it is so? It is given in the problem itself, it is given, and again AC is equal to CA because they are common sides to both the triangles, and angle 1 is equal to angle 2, so they are again alternate angle. okay, alternate angle, and DC is parallel to AB and CA is transverse. So what we get, that triangle ABC is congruent to triangle CDA, right? If that is so, if these two triangles are congruent, then each and every parts are equal, and definitely this angle will be is equal to this angle. Suppose this is angle 3 and this is angle 4. So what we get, therefore angle 3 is equal to angle 4. But you see, this angle is what? This is the transversal, and this angle is equal to this angle. So these are alternate angle again. But DA and CB is not parallel. This is not given. But what we get, that these alternate angles are equal. So you can write alternate angle. So if alternate angles are equal, then CA is transverse. Therefore, AD is parallel to CB, and this is CA is already a transversal. So what we get finally, AD is parallel to CB. That means these pair of lines are also parallel and equal. It's already equal because of the congruence. This is already equal. AD is equal to BC. This is already equal because of the congruence of the triangles. Now we get AD is parallel to CB. So if AD is parallel to CB and AD is equal to CB, what we get? In this quadrilateral, all opposite sides are equal and parallel to each other. So this is a parallelogram. So this is proof that such a quadrilateral is a parallelogram which has a pair of sides parallel and equal. Okay, theorem number 5. Diagonals of a rectangle are equal and they bisect each other. We have to prove that. First we will prove that the diagonals of a rectangle are equal. ABCD is a rectangle, and we have to prove that diagonal AC is equal to diagonal BD. So to prove that, we will take two triangles, triangle ABD and triangle BAC. So actually we will take these two triangles. For the convenience, I am drawing it. So what is this angle? This is ABD triangle, and this is again ABC triangle. So in this rectangle, we take triangle ABC and triangle BAD, these two triangles, BAD and ABC. So in this triangle, this is a rectangle, you remember. So if it is a rectangle, then this side is equal to this side. So DA is equal to CB. Here, this side is equal to this side. Then side AB is equal to side B. It's a common side. AB is equal to BA, common. You can write common. This is DA equal to CB. Why it is so? These are opposite sides of a rectangle. Then this angle is 90 degree and this angle is 90 degree. Because it is a rectangle, in a rectangle all sides are of 90 degree. So this angle is 90 degree each. So you can write angle BAD is equal to angle ABC, 90 degree each. So both the triangle ABC is congruent to triangle So if that is so, therefore you write AC is equal to BD. So these are the diagonals of the rectangle. So we have proved that diagonals of the rectangles are equal. Now we have to prove that they bisect each other. So we'll again consider this diagram. ABCD is a rectangle and AC and BD are two diagonals and they cut at point OC. So we have to prove that OA is equal to OC and OD is equal to OB. So let us do this. So you consider the triangle OCD and OAB. So triangle OAB and triangle OCD. In this triangle you see AB is equal to DC. Side AB is equal to DC. Why they are equal? Because they are the opposite sides of a rectangle. Now you see this angle say 1 is equal to this angle 2. Angle 1 is equal to angle 2 because they are alternate angle. They are alternate angle because DC is parallel to AB and CA is a transverse. Similarly, this angle, say this is angle 3 and this is angle 4. Angle 3 is equal to angle 4. They are also alternate angles. Therefore, triangle OAB is congruent to triangle OCD. So both these triangles are congruent, and if that is so, OA, OC and OB is equal to OD. So what does it mean? That AC bisects DB and DB bisects AC. That means they bisect each other. So this is the proof of theorem 5. Now theorem 6. Diagonals of a rhombus bisect each other at right angles. Two things we have to prove, that they bisect each other and they bisect at right angles. So they bisect, that this can be proved because rhombus is a parallelogram. So we have already proved that if this is the point of intersection, then this angle is equal to this angle, alternate angle, and this angle is equal to this angle. They are also alternate angles, and this side is equal to this opposite side of a rhombus or parallelogram. So these two triangles are congruent, and if that is so, this is equal to this side and this side is equal to this side. So this is the proof that the diagonals of a rhombus bisect each other. So what we get from bisect, actually OA is equal to OC and OB is equal to OD. They bisect, and this we use to prove that they bisect at right angle to each other. So if this is the point of intersection, so now we will take these two triangles, this triangle and this triangle. Okay, so you write in triangle OAB and see these two triangles, what are equals? So you see this side is equal to this side, that means AB is equal to BC. Now why it is equal? Because they are the sides of a rhombus. The sides of a rhombus are equal. Then this is equal to this side. You write OA is equal to OC. We have proved it here in the first step. So you can write diagonals of a rhombus bisect each other. Then again OB is equal to OB, the common side. So triangle OAB is congruent to triangle. If these two triangles are congruent, and this is side, side, side postulate. Okay, according to SSS postulate, these two triangles are equal. Therefore, angle AOB is equal to angle COB. That means this angle is equal to this angle. But what we get? Angle AOB plus angle COB is equal to 180 degree. You can see this angle is 180 degree. Angle AOB is equal to angle COB is equal to 90 degree each. What does it mean? That they intersect at right angles to each other. This is at right angles, they intersect. Okay. Now theorem 7. Diagonals of a square are equal and bisect each other at 90 degree or at right angles. So diagonals of a squares are equal, that we can easily prove. Already we have proved the same thing for a rectangle. So in the squares also it will be same. The thing is that we have to take this triangle and this triangle first, and then we can prove that they are equal, diagonals are equal. So we can easily prove that AC is equal to BD. They bisect at each other. So that means if they intersect at point O, then this is equal to this and this is equal to this. This also we can prove easily because we have already proved in rectangles. This is square. Square is a special rectangles only. So what we know, OA is equal to OC and OD is equal to OB. Say we know this. We have to prove this first, then only we have to prove that they intersect at 90 degree. So for that again we will take this triangle and this triangle. So in this triangle you see this side equal to this because they bisect, and this side is equal to this. This is the sides of a square and this side is common side. Triangle AOB is congruent to triangle COB. It is side, side, side congruence. Angle AOB is equal to angle COB. So if this is equal to this and this whole angle is 180 degree, then definitely you can say they are actually what? That this angle is 90 degree, this angle is 90 degree, equal angle, then only it will be equal to 180 degree. They are supplementary angle. So this plus this equal to 180 degree. Then definitely AOB is already equal to COB is equal to 90 degree. Proved. Now the last thing, a kite. What is a kite in geometry? A kite is a quadrilateral whose two pairs of adjacent sides are equal. In this quadrilateral A, B, C, D, AB is equal to BC, adjacent sides are equal, and this is one pair, and again this is equal to this side, that means AD is equal to CD. These are also adjacent sides. So this type of quadrilateral is called a, okay, this is called a kite. So in the next video we'll do all the exercises of chapter 17. Okay, till then, thank you.